Welcome back to Simplifying Complex Rational Expressions. We are now going to look at what happens when you have exponents to a negative power. What this means is what was originally in the denominator has been written as a term in the numerator. This x to the negative 1, that's equal to 1 over x. And y to the negative 1 is equal to 1 over y. So if you think about it that way, you could rewrite this as 1 over x plus 1 over y, all divided by x squared minus y squared over xy. So if I look at my denominators, I have an x and a y. I also have an xy, a product, in the denominator's denominator. So now I'm going to multiply by the LCD. The LCD is the greatest number of times a factor appears in any one factorization, and in this case it is xy. So I'm going to multiply the numerator by xy and the denominator by xy. Notice I put it over 1 just to make it more easily, follow. You can track the steps a little better, maybe, that way. If I distribute xy in to my first term in the numerator, I'll have xy over x. That will reduce to a y. Now I will distribute the xy to the 1 over y. That will reduce, and I will have an x. In the denominator, I'm going to distribute that xy over 1 to each term inside. Notice that I basically just have one term. If I were to distribute that xy as a fraction by multiplying to the x squared minus y squared over xy, the xy's will divide out. So I'm simply left with the numerator in the denominator, x squared minus y squared. Now I'm going to factor the denominator. X plus y, x minus y are the factors, binomial factors. And notice that y plus x and x plus y don't matter what order they're in. So I'm going to reduce those. So my final answer, it's not 0 in the numerator, it's 1. You have 1 over x minus y. This next complex rational expression has trinomials in the numerator's denominator and the denominator's denominator. So I'm going to kind of break these apart, and I'm going to actually rewrite this as a fraction divided by another fraction. So I have a squared minus 4 over a squared plus 3a plus 2. And then I'm going to put a division symbol and then the denominator. A squared minus 5a minus 6 over a squared minus 6a minus 7. And now I'm going to try and factor these fractions after I flip the second fraction over and multiply. So if I flip this second fraction over, I'll have a squared minus 4 over a squared plus 3a plus 2 multiplied to the reciprocal, which is a squared minus 6a minus 7 over a squared minus 5a minus 6. If I factor the numerator, I'll have a plus 2 times a minus 2. I'll have an a minus 7a plus 1. Those are both the numerator factors. In the denominator, I'll have an a plus 1 and an a plus 2. And the last trinomial will factor to an a minus 6, a plus 1. And now I can just reduce, just like we were doing previously. I'm looking for an a plus 2 to reduce, and there is one. I'm looking for an a minus 2, and I don't see one. I'm looking for an a minus 7, and I don't see one of those. I'm looking for an a plus 1, and one of those does reduce. So now my final answer for this is a minus 2 times a minus 7 all over a minus 6 times a plus 1. And we're done. So I have 3 over a minus 3, a minus 1, there we go, plus 3 over, all over, a minus 3, a minus 2. And then in the denominator's denominator, we have 3 over a minus 2, a minus 1, plus 3 over a plus 5, a minus 2. So now I need to look at all my denominators and figure out what the LCD would be. If I look at how many times a minus 3 appears, it appears once. A minus 1 appears once. A minus 2 appears once. And a plus 5 appears once. So that's what I need to multiply the numerator and the denominator by to get rid of the denominators in all those fractions. So I'm going to do that next. So here's my funny looking fraction. I have a minus 3, a minus 1, a minus 2, a plus 5. That's my numerator, and then also in the denominator. And then I'm just going to distribute that through. So when I distribute in, I have to think about my fractions in the numerator and my fractions in the denominator. When I distribute this grouping in, the a minus 3's and the a minus 1's will reduce out. They'll divide. And so I'll be left with 3 times a minus 2 times a plus 5. If I distribute to the next term or fraction in the numerator, I'll be left with 3 times a minus 1 times a plus 5. And all my fractions in the numerator are gone now. So the same pattern will happen in the denominator. We'll have a minus 2 and a minus 1 divide out, and a minus 3 will stay, and a plus 5 will stay, plus 3 times a plus 5 will divide out, and a minus 2 will divide out, and we'll have a minus 3 left and a minus 1 left. Now I'm going to FOIL these and combine them. A minus 2 times a plus 5 is a squared plus 3a minus 10. A minus 1 times a plus 5 is a squared plus 4a minus 5. A minus 3 times a plus 5 is a squared plus 2a minus 15. And a minus 3 times a minus 1 is a squared minus 4a plus 3. Now I distribute the 3 in. Combining like terms, 6a squared plus 21a minus 45 all over 6a squared minus 6a minus 36. Now hopefully, I paused for a moment. Hopefully you noticed that you could have factored the 3's out. It didn't even occur to me while I was doing this, but you could totally factor the 3's out, and it's not too late to do that now. If you factor a 3 out, you will have 2a squared plus 7a minus 15 all over 3 times the quantity 2a squared minus 3a minus 12. You can try factoring this further, but I can tell you that it doesn't work. So we'll go ahead and just reduce this here. And your final answer, after all that work, is 2a squared plus 7a minus 15 all over 2a squared minus 3a minus 12.